Good day, learners. Welcome. Today's lesson on geometry of 2D shapes. We are continuing with solving problems, and specifically we are going to look at practice questions. 1. In triangle PQR, PQ is equal to 12 centimeters. What is the size of each angle in the triangle PQR? So look at the markings. The fact that this is 12 centimeters, we'll look at that later on. Let's look at the fact that the three sides are equal. If the three sides are equal, that means the angles are also equal. What we call such a triangle where all the three sides are the same, are equal, we call it an equilateral triangle. Already we've answered question B. So with that knowledge, what do we know is that all the angles are also equal. So that angle equals to the P equals to angle Q equals to angle R. And therefore, we know that angles of a triangle equal to 180 degrees. And so we divide with three angles and we have 60 degrees each. So each angle is going to be 60 degrees. P is going to be 60 degrees. R is going to be 60 degrees. And Q is also going to be 60 degrees because they said each angle. Okay, let's look at another one. Given triangle LMN with markings, there it is. What is the special name of this triangle? A triangle that has that side and that angle and that angle, angle M and angle N have the same marking, they are equal. What triangle is that? A triangle that has two equal angles and means that the opposite sides of that triangle are also equal. It's called an isosceles triangle. Isosceles triangle. And then, what is isosceles triangle? And then calculate the value of x, angles of a triangle equal to 180, the sum thereof. So we then do the same. We say x plus 2x plus 12 degrees equals 280. Again, I always said, when you make a statement, you need to have a reason for it. We are saying this is the sum of angles of a triangle. Then x plus 2x is 4x plus 12 degrees, which equals to 180. And then additive inverse of 12 leaves us with 4x equals to 180 minus 12, and that would give us 168 degrees. And then 168 degrees. So we need the multiplicative inverse of 4, which is a quarter, and therefore we say 4x divided by 4 will be equals to 168 degrees divided by 4, and therefore our x value would be 168 divided by 4, which gives us 42 degrees. So our value of x is 42 degrees. Then the next question, what is the length of LN? Look at that. LN, this is, as we said, this, if this angle x equals to n, angle M equals to angle N, therefore that means this side is equal to that side because this is an isosceles triangle. And because of that, that means LN equals to 3 centimeters. And the reason for that is it's an isosceles triangle. Where the sides opposite equal angles are equal. Okay, let's then look at the next one. Calculate the value of x in triangle PQR. Again, we know that angles of a triangle equals to 180. So we know that angle P plus angle Q plus angle R equals to 180 degrees. And then angle P is 2x plus angle Q, which is 2x plus 10 degrees. And angle R, which is 5x minus 10 degrees equals to 180 degrees. Reason here is that these are the sum of angles of a triangle. All right, and therefore we add like terms. There are the like terms, all the x's together. And then it gives us 2x plus 5x is 9x. And then 10 degrees minus 10 degrees is 0. So we've got 9x equals to 180 degrees. And then the multiplicative inverse of 9 is a ninth. Therefore, we divide by 9 on the left and divide by 9 on the right. And then x equals to 20 degrees. So our value of x is 20. Let's look at the next question. Now they say, determine the size of angle J and angle M if angle J is twice angle M. Let's look at the diagram and see where angle J and M are. And you'd see that these are parallel lines, and angle J and angle M are between the parallel lines. And therefore, what do we know about angles that are between parallel lines and on the same side of the transversal? They are said to be co-interior. Therefore, we say angle J plus angle M equals to 180 degrees because line JK is parallel to line ML, and therefore co-interior angles are supplementary. And therefore JK plus angle J plus angle M equals to 180 degrees. Now let's look at that question again. It says angle J is twice angle M. So in the place of J, we can actually use 2 times M, which is 2 angle M plus angle M equals to 180 degrees. So now I have 2M plus M, which would mean 3M equals to 180 degrees. And the multiplicative inverse of 3 is a third. Therefore, I will divide by 3 on the left, and it divide by 3 on the right, and then my angle M will be equals to 60 degrees. Therefore, angle J would be equals to 2 times 60, which is 2 times 60 degrees, which is 120 degrees. Now, the B part of the question, if JM is 9 centimeters, JM is 9 centimeters, and perimeter is 58 centimeters, calculate the length of ML. Again, what do we see on the diagram? Let's use a different ink for this one. What do you see on the diagram? You would notice that there is a marking there that makes those two sides equal, and a double marking that makes those two sides equal. Therefore, that means JM plus KL plus JK plus ML equals to 58 centimeters, because that is the perimeter. So perimeter is the distance around the object, or in this case, so when we add all those 4 distances, we then need to get 58. And what do we know is that JM is 9 centimeters, and the side that is equal to JM, which is JK, is also KL is 9 centimeters, and then JK and ML are equal, so we'll write that as JK multiplied by 2 because it's the same side, which equals to 58 centimeters. Now, 9 plus 9 is 18 centimeters, plus 2jk equals to 58 centimeters. Let me write that 58 properly. 58 centimeters, and therefore the additive inverse of 18 is negative 18. So it will be 18 minus 18 plus 2jk equals to 58. What we do on the left, we also do on the right. So we're going to add negative 18 on the right as well. So that we have 2jk equals to 40. 58 minus 18 is 40. And therefore, if 2jk equals to 40 and the multiplicative inverse of 2 is a half, so we divide by 2 and divide by 2. So jk equals to 20 centimeters. So that is our side, which would be, because jk equals to ml, therefore ml also equals to 20 centimeters. All right. Let's look at the next one. DEFG and JKLM are parallelograms. DEFG is twice the size of JKLM. Now prove that DEFG is similar to JKLM, and why? The word twice means that whatever we have on DEFG, we should have half of it on the other one. So if there's 4, this one would be 2. If there is 2, this one would be 1. And that goes on for all the other sides. The word parallelogram means that whatever happens on this side would happen on the other opposite side as well. Whatever happens on JK would be happening on ML. So that's what it means, information as given. And therefore, proof that they are similar would be to say, if we divide side JK and divide it with side DE, it means that side JK, which is 2, and DE, which is 4, 2 divided by 4 gives us a half. And then let's look at the other pair, and that would be JM divided by DG. And that would be 1 divided by 2, which is already a half. So I've got a half and I've got a half, and that will happen to all the sides. And therefore we say, therefore, DEFG is similar to JKLM, because the corresponding sides are proportional. All right, let's stop there for now. Let's go for an ad break. See you shortly. Welcome back. Let's continue. We're now going to look at application questions in problem solving on 2D shapes. Question 1. KLMN is a quadrilateral and KT is perpendicular to KL. As the diagram shows us, perpendicular makes that angle 90 degrees. Now the question that they're asking is, if angle KTL, that angle there, is 56 degrees, let's mark it so that we can see it, 56 degrees, determine the size of angle KLT, that angle there. That's the one they want us to find, and we need to give reasons for that. All right, I noticed that I am now dealing with a triangle KTL. So I will then start with in triangle KTL, because that's what I'm looking at. I noticed that angle K, okay, LKT, that 90 degrees there, angle LKT plus angle T, okay, KTL, plus angle KLT, Remember, that's how we name a triangle, where it begins, where the angle is, and where it ends. All right, all three of them must be equals to 180 because this is a triangle, and the sum of angles of a triangle must give me 180. Don't forget to always accompany your statement with a reason. Let's continue with our calculation. The first angle we were given is 90 degrees. The next one is 56 degrees. And angle KLT equals, it's the one we want, and they are equal to 180 degrees. 90 plus 56 is 146 degrees plus KLT equals to 180 degrees. 146 degrees plus KLT equals to 180 degrees. And the additive inverse of 146 degrees is negative 146 degrees. So we add it in there, plus angle KLT equals to 180 degrees. And again, we need to subtract 146 degrees as we did on the left. And so the outcome would be angle KLT would be equals to 180 minus 180 degrees minus 146 degrees, which gives us 34 degrees. So our value for angle KLT is 34 degrees. Let's put it in the diagram just to remember that we have already answered that part. And then the B part of the question is, what is the size of angle LTM, and explain why. Where is LTM? When they say angle LTM, we start from the first letter L and then to where it turns on the next letter T and go towards M. So that angle there is what they are looking at. When I look at that angle, I realize, let me change my ink so that you notice that this is a different question. That angle there. So what do you notice is that when I look at that angle there and the angle that we've just calculated, which is the angle KLT, and the two angles are positioned, one is on the right, the other one is on the left of the transversal that is between two lines, KL, which is parallel to MN. And so when I look at that, I'm able to say angle LTM is equals to angle KLT, which equals to 34 degrees. And the reasons for that is because line KL is parallel to line MN, and therefore alternate angles are equal, and therefore that is the value of that angle there. So it would be 34 degrees. All right, let's move on to the next one. The next question. Triangle FGH and triangle LMN are similar. Angle H equals to angle N, which equals to 72 degrees, and angle G equals to angle L, which equals to 65 degrees, and line LN equals to 2 centimeters, and HG equals to 4 centimeters. Let's put in the values so that we would see what that means. That means angle H is 72 degrees. 72 degrees. And angle N is also 72 degrees. And then angle G is 65 degrees. And angle L is 65 degrees, according to information given. And LN is 2 centimeters, and HG is 4 centimeters. Now, question 1 says, or A part of the question says, if LN is 7, LM is 7 centimeters. Calculate the length of FG. All right. What do you notice about our triangles is that we've got angles that are similar. These two triangles are similar, and therefore that means the sides are proportional. Let's first find the first part of the proportion, which is what we are given, which is ln divided by hg, and it must be equal to what they want us to now find, which is lm divided by fg. So what are the figures of ln? ln is 2 and hg is 4, and we are told that lm is 7 and fg is what we do not know. Can we look at what we have? You would see that on the numerator I've got 2, on the denominator I've got 4, so which means the denominator is multiplied the numerator by 2. So if on the right I have a denominator of 7, therefore the numerator will be multiplied by 2. So FG, therefore FG will be equals to 14. FG will be equals to 14 centimeters based on proportion of the sides. These sides are in proportion. Let me write that so that we remember that sides are in proportion. Corresponding sides are in proportion. Corresponding sides are in proportion, therefore FG would be equal to 14 centimeters. Now let's look at the next part. Determine the size of angle M and give reasons for your answer. LMN is a triangle. I already know the two angles of that triangle. And what do we know about a triangle is that angle L plus angle M plus angle N should give me 180, because this is the sum of angles of a triangle. And therefore, if L is 65 and M is unknown, but N is 72 degrees, and they are equal to 180 degrees. And therefore, 65 plus 72 would give us 137. So angle M plus 137 degrees would be equals to 180 degrees. And the additive inverse of 137 degrees is negative 137 degrees. So angle M plus 137 degrees minus 137 degrees would be equal to 180 degrees minus 137 degrees. And then, so therefore, angle M would be equals to 180 minus 137, which gives us 43 degrees. The next question is question 7, which reads as follows. ABCD is a quadrilateral with AD parallel to BC. There's AD parallel to BC, and AB equals to DC. So a marking there and there, and then AE equals to DE, AE equals to DE, marking there, which equals to 4 centimeters. 4 centimeters. And then BE is equal to, I'll put 3 markings there, equals to CE, which equals to 8 centimeters and 8 centimeters. Now, the question then, A part says, name 3 pairs of congruent triangles with reasons. There are a lot of triangles in there, but let's look at congruent triangles, which means triangles that have equal sides. Remember the conditions of congruency? So corresponding equal sides on corresponding equal angles. Let's look at what we have in front of us. The first pair is AEB and triangle DCE. That is the first pair of congruent triangles. So it's triangle ABE and triangle DCE. And my reason for that is that I'm already seeing a sign that says, look at the markings. There are 3 markings on the triangle and 3 markings on the other triangle. So all the sides are equal. So it's side, side, side. Part 1 done. Let's look at the next triangle, a pair of triangles that are congruent. Let's look at triangle ABD. Triangle ABD. And look at triangle ABD and triangle DCA. So triangle ABD and triangle DCA. What do we notice about those 2 triangles? Is that already there is a side DC that is equal to AB, and we have a side that is 8 plus 4, 8 centimeters plus 4 centimeters, and on the other triangle we also have 8 centimeters plus 4 centimeters. So we have another side that is equal, and we have 29 degrees and 29 degrees. So the reason for that one would be side and the included angle and another side, and therefore that would be the reason for the second pair of triangles to be congruent. Now let's look at the third pair of triangles that are congruent. Now let's look at the third pair of triangles that are congruent. I am looking at triangle ABC, and triangle BCD, triangle BCD. One is at the left bottom and the other one is at the right bottom of that figure that we have there. And when you look at that, you would see that one, we already have AB equals to BC, so that's one side that is equal. Then we have the side that we said was 8 plus 4 centimeters, and the other one also has 8 centimeters plus 4 centimeters, so that 12 centimeters and 12 centimeters, that is a common side as well. And we also have side BC. They both have side BC, which is common. So therefore, those 2 triangles are congruent because all the sides are equal. So now we have established 3 pairs of triangles that are congruent in that diagram alone. Let's continue and look at number B of this question. And it says, calculate angle DEC. Angle DEC is that angle there. Angle DEC is that angle there. And what do you notice is that it is adjacent to angle 122 degrees. So we're going to write it as angle DEC plus 122 degrees equals to 180, because angles, let me write that proper, angles on a straight line are supplementary. So angles on a straight line are supplementary, therefore that means that we need to now find the additive inverse of 122 degrees, which would be negative 122 degrees. So angle DEC plus 122 degrees minus 122 degrees equals to 180 minus 122 degrees. And therefore, angle DEC would then be equals to 180 degrees minus 122 degrees, which would give us 58 degrees. It would give us 58 degrees. So our value of angle DEC is 58 degrees. Right, look at the next question. ABCD is a quadrilateral with AB parallel to BC, AB parallel to BC, all right, and AB equals to BC, all right, and AD parallel to BC, and then AE equals to DE, AE equals to DE, and they're equals to 4 centimeters. And then BE, where's B? BE is equals to EC, and they are equals to 8 centimeters. Now, name 3 pairs of congruent triangles with reasons. Which triangles have the same markings that we would see in that diagram? The first pair is AEB. They have 3 markings of 3 sides that are equal. So the first one is triangle AEB and triangle DEC. That's the first pair. The next pair that is also congruent is triangle, I'm looking at that triangle there, ABD. Triangle ABD and triangle ADC. Triangle ADC. That's the next pair. And the other pair of triangles that are congruent is triangle ABC, triangle ABC, and triangle BCD. Triangle, sorry, I forgot to write triangle. Triangle BCD. Those are the 3 pairs of triangles that are congruent. And then, because all the sides are equal, all sides are equal. All right, calculate the angle DEC. DEC, that angle there. That's the angle we are supposed to calculate. Look at where the angle is sitting. The angle is sitting on a straight line with the 122. So it's going to be angle DEC plus 122 degrees equals to 180. These are supplementary angles. And therefore, angle DEC equals to 180 minus 122 degrees. And therefore, angle DEC equals to 58 degrees. That's our value of that angle. Let's stop there for now and go for an ad break. See you shortly. Welcome back. Let's continue with our lesson. We are now going to wrap up what we have been saying in this lesson. We start with the concept map, and we looked at the 3 sections, the properties of triangles, properties of quadrilaterals, and we were solving problems. Just a recap on the words that we have learned in this lesson, and they are congruent, meaning that the shapes were the size of the corresponding angles and the corresponding sides are equal. Remember, corresponding means that if you are looking at that side on the left of that diagram, you will also be looking at that left-hand side of the next diagram. And the same with the angles, corresponding angles. If you are looking at an acute angle of that diagram, you then find a corresponding acute angle or in the next diagram, because that's what corresponding would mean. And then the next word that we've learned is similar. Remember, similar is the shapes are the same, but not necessarily equal. And the corresponding angles, again, the corresponding angles are equal. And remember, I wanted to use set squares so that you are able to remember them as an instrument we use to draw angles. So that one is 90 degrees, irrespective of size, and the other one is 30 degrees, and then the third angle is 60 degrees. That's why it's called a 30-degree set square. It is the set square that has a 30-degree angle. And therefore, the corresponding angles would be those, and corresponding sides would be the shortest side on this one would be in proportion with the shortest side in the next figure. So that's when we say they are corresponding sides and they must be in proportion. Remember, proportion means the ratio that you get when you divide the two sides must be equal to the ratio that you will get when you divide the other corresponding two sides in that diagram. Let's look at today's challenge. In the shape ABCDEFG, angle FBC is 117 and angle F is 37 degrees. They have been marked, as well as that angle GED, which is 133 and 33 degrees. Now determine the size of angle A. Angle A is that angle on the top there. How do we get to angle A? To assist with that challenge, you need to look at angles on a straight line, and then you need to look at angles of a triangle. You need to look at vertically opposite angles, and then you go to that triangle. When you are in that triangle, you need to realize that there is angles of a straight line, and then when you add those angles, you should be able to find angle A. Have fun with the challenge. Thank you for joining me. That's all for today. Hope to see you next time. Goodbye.